Hello, my amazing students. We are here with 5.5 of college algebra, and I am going over the PowerPoint questions at the end of the PowerPoint so that you can see how the problems are done. And this is especially helpful because I'm using the test bank to generate these problems. So these are definitely problems that you could see on a test, or similar to these. So the first one that we're doing is number 1. And we're just raising 5 to some power to get 125. All right, so we're going to use the property that we're going to use is just to say, okay, is 125 equal to 5 to the something? And it is 5 cubed. So this may be going just a little bit overboard with this one, but it's to stress a principle. Once we get the two bases equal to each other, then we're allowed to set the exponents equal to each other. So we got x must be equal to 3. And that's one maybe you could have done in your head, but the principle is still very important that when we can, we're going to try to change the base from 125 to 5 if possible. And then once we do that, we're able to set the exponents equal to each other. Okay, we're going to use that same principle in this one. Okay, this is number 2, and we have 3 raised to a power is 1 over 729. Well, 729 is a big number, but if you look at it, 729 divided by 9 is going to be 81, and 81 is 3 to the 4th power. So I have 3 to the 2nd power times 3 to the 4th power, which means that altogether that is 3 to the 6th power would give me 729. But the 729 is in the denominator. So instead of 3 to the 6th power, I'm going to say that this is equal to 3 to the negative 6th power. And then I'm going to erase that so I get some room. That is equal to 3 to the x squared plus 5x. Okay, so now I do have the same base on each side of the equal sign. So I am able to use this principle to set the bases, the exponents equal to each other. So we get x squared plus 5x equals negative 6, which means that I can write this as a quadratic expression in standard form, x squared plus 5x plus 6 is 0, okay? And that is going to factor into x plus 2, x plus 3. So when I factor it, I get x plus 2 times x plus 3 equals 0, which means that x is negative 2 and x is negative 3. Okay, so we should go back up there and plug that in to make sure it is true, but those are indeed the answers that I have in my answer key. So those are right. Okay, so getting the base to be the same on both sides of the equation makes these pretty easy. Okay, number 3, I may have attempted to do in class. I didn't realize at the time that, this is only to be done with a calculator. So we're going to do this one with a calculator now. So this is not one that you can just do off the cuff here. So we're going to use our y function, and we're going to put the left-hand side in. So we're going to say e to the x plus e to the negative x. So that's going to be second e to the x, and I'm going to plug in the x, all right, so, and then plus, so I'm going to show you how to do the second one here, e to the negative x, I'm going to go to my second, and then down here to my natural log is my e to the x, and you can see that I'm getting an e to the x up there. I'm about to sneeze. And then I'm going to plug into the parenthesis a negative x. I'm going to use this negative, not this negative. This is the minus negative. This is the change sign negative down here. So I'm going to hit that one and then hit the variable key up here, which is on your x, tau, theta, n key there. Okay, it's got a lot of numbers. And then I'm going to close my parenthesis off. So on the left-hand side, I've got e raised to the x plus e raised to the negative x. Hopefully you can see that on the screen. Okay, and then on the second side of the equation, I'm going to just put a 6. So my y2 is going to be equal to 6. So y2 is equal to 6. So I plug that in. And now I am ready to graph my functions. But I probably need to make sure that my window is going to be all right. Now remember that e to the x should be coming right there and going sweeping up this direction, and then e to the negative x should be coming the other direction and going up like this. Okay, so up here at 6, we're looking for these intersection points. So we know that our y value, we only need to go up a little bit above 6 to be able to get those. And our x value is going to climb up to 6 pretty quickly. So we can probably get a real good window if we just do -5 to 5 on the x and then do 0 to 10 on the y. We should get a real good picture. So I'm going to adjust my window to show those values. So I'm going to do -5 to 5 on my x, and I'm going to do a scale of 1 because I had that changed in another problem. And then I'm just going to do 0 to 10 on the y and a scale of 1 also. So my window I'm going to have looking like this. There. Hopefully you can see that. There, that's a little clearer. So always adjust your window. So then when I graph it, I should see something happening there. Ooh, cool. All right, now it is doing pretty much what I thought it was going to do, because remember that I started at, I made my y 0 to 10. So shouldn't this cross the axis at 1? Okay, and it does. It's a little bit off the bottom line. It crosses the axis as 1. This is your y is equal to 6 line that's running across the middle. And so now to find the intersection points, I'm going to calculate the intersection. So I'm going to go second, calculate, and then I'm going to come down to number 5, which is the intersection, and I'm going to hit enter. And then it's going to position the cursor right down here at the bottom. It says, am I on line or curve 1? And I said yes, and then it's going to put it up there on the other axis and said, am I on the y is equal to 6 line, which is number 2? And I said yes, just hit enter. Would you like me to guess? Please do. So I'm going to say yes. All right, so it's going to give me an intersection point. Now notice, it only gives me one intersection point at a time. I have to go through the whole process to get this other one, and I'm probably going to have to put it at a different spot on the curve because it looks closest to where you are. So it went to the right this time to get it. So the intersection that they give is 1.7627, and then of course y is 6. So now I'm going to go through the whole process and see if they give me on the one on the left. Now since these are mirror images of each other, then shouldn't it be negative 1.7627? It should be. So let's see that it is. So I'm going to go and move my cursor. I'm going to do the second calculate again. I'm going to do intersection again. I'm going to move my cursor over to the left because I want the left-hand 0 or intersection point. So I'm going to hit it. Yes, I'm on the first curve, and yes, I'm on the second curve, but I'm doing it right up there close to the left-hand intersection, which is the one I want now. And then, would you like me to guess? Yes, please guess. Okay, and they guess negative 1.7627. Okay, which is exactly the opposite sign of what we had before. So plus and minus are the two intersection points. So that would be, remember, these are the x values of each one of those points. The y values of both of those points are 6 because that's the intersection line. So we get x is plus or minus, and that is the answer. They give a 1.763, but when you round this to 3 decimal places, that would be correct. Okay, so 4 decimal places is always good. I prefer 4, but this one did it in 3, which is fine. Okay, so there is your answer, calculator problem. Now the next one is also a calculator problem. Okay, so here we are. We've got e to the x plus e to the negative x divided by e to the x minus e to the negative x. Okay, so what we're going to do is we're going to plug in the two functions together. So I'm going to do this one the same way I did the last one. I'm going to take my calculator. I'm going to go to y. I'm going to clear out the y1. I'm going to clear out the y2 and get my calculator all clean so nothing's in there. Then I'm going to go to the y1 and I'm going to put everything on the left and the 5 on the right. So my left-hand side is going to look pretty complicated. My right-hand side will be very simple. Okay, now I could cross multiply and write the function differently if you wanted to, but I'm just going to use parens and a division sign and some more parens to keep everything accurate. So I'm going to do parenthesis and then second function e to the x, and I'm going to plug in my x, and I'm going to close my parenthesis, and then I'm going to do a plus, and I'm going to do second function e to the x, and this time I'm going to put in a minus x, or a negative x, not a minus x, because I'm going to use the one down here at the bottom of the screen. And then I'm going to make sure that I close that parenthesis. I'm going to divide. I'm going to start another parenthesis. I'm going to do the whole thing over, except now I've got on the bottom an e to the x minus an e to the x. Now this is number 4 in your problem set at the back of your PowerPoint. So we end up with e to the x again, and close that parenthesis, and then I'm going to use minus, and then second e to the negative x. Okay, now this one should work, and then I'm going to close the second parenthesis. So basically, I have to make sure that all of my parentheses are closed, and it looks like one of them is open. So I'm going to go up there and put in another parenthesis here, because I think I basically neglected to close a parenthesis, so I'm correcting that now. Okay. All right, I think I finally got it right. So you can see what I have on my screen. I had several different little issues that I had to go back and fix. For one, I had used, somehow I had gotten my second key and I'd done a parenthesis, but it put a little brace instead of a parenthesis, which gave me a syntax error. So you really have to work hard not to make an error on these. So hopefully you can get yours in like mine. So I put on y1, I put the left-hand side, and y2, I put the 5. So basically I took this equation and I stuck it in the calculator, with the y1 being all the e stuff, and then the y2 being the 5, so that when I graph it, I get this really cool graph like this. Okay, so it basically, you can't see it very well, but it comes down here and does a little thingy down here as it's going across. But that's what it looks like. So we're looking at one intersection point, which should be slightly to the right of the y-axis. So we're looking for this point right here. Let's see if I can do it, where it is crossing the line y is 5 there. So to find that, we're going to use intersection again. So we're going to go to second, calculate, and we're going to go down to the intersection function. Okay, so now it's going to do first curve, second curve, and so first curve, I have to find out where they've got my cursor. So they've got my cursor on the line, so I'll say yes, that's good for my first curve. And then they're going to put the second one, and I can't even see the cursor, so I'm going to have to go find the cursor on the second line so that I can put it on the second line. Okay, so now I've got it on the second line, and I'm going to hit enter. Would you like me to guess? So they're guessing, and they say 2.02 something. 2.0, no, point 0.2027. Point 0.2027. Okay, and when I look in the answer key, it is 0.203, which is fine. So 0.2027 or 0.203. So basically those two are just calculator problems. No other way you're going to get them done. So just enjoy playing with your calculator on those. So the next one that we're going to do is number 5. And it is basically log of x is -4. So again, this is going back to the logarithm. We're changing the logarithm into an exponential to make it easy to solve. That's the way I do it. So basically, when I'm taking a logarithm, I'm not as familiar with logarithms as I am with exponents, but I do know my base is 10 because this is a common log. So 10 to the -4 is x. You turn that thing around, write it in its exponential form. 10 to the -4 is the same thing as 1 over 10 to the 4th, which is the same thing as 1 over 1, 2, 3, 4 zeros. Okay, so they put the answer as 0.0001, and I wrote mine as a fraction. That means the same thing. So whether you write 1, remember 0.0001, this is the 10th place, 100th place, 1000th place, 10,000th place, and we have 1 over 10,000. So whether you write it as 0.0001 or 1 over 10,000, they are both correct. Okay, so I'm about to have to go teach a class, and so I want to finish this video so that you at least have this one, and I want to be able to put it online. So the problem is number 6 on the video is log base 6 of x is -5. So all we have to do is turn the equation into its exponential form, which is going to be 6 to the -5 is equal to x, okay, and it's always base to the exponent, gives you the argument, and then 6 to the -5 is 1 over 6 to the 5th, which is the same thing as 1 over, stick it on your calculator, 6 to the 5th is 7,776, and that is the correct answer. So the original problem looked like this, and that is the answer right there. So I'm going to try to finish this one before I go in to give a final here or a test. All right, so problem number 7 on 5.5 is log base 5 of 3x minus 7 is 1. We're going to turn it around into its exponential form, which means 5 to the 1 is 3x minus 7. Okay, so 5 to the 1 is just a 5. So then we add a 7 to both sides, and we get 12 is 3x, or x is 4. And then we do need to check it back in and make sure that that is a good answer. So we plug the 4 back in, we get 12 minus 7 is 5, and we do know that log base 5 of 5 is 1. That is one of our properties. And so that is the correct answer for that one. All right, so this is our last problem, and it is kind of a combo of some of the properties. I don't know if you can tell. There's my steering wheel. I'm in the car trying to get this last problem done so I can post this for you. So we have a log of something minus a log base 10 of something. They're both log base 10, so we should go back and write this as one single logarithm. We're going to write this as the log of the quotient. So that's going to be log of x plus 10 over x plus 4. So we're going backwards and we are writing it as a single log, and then we can say it's equal to the log of x. So since we're log base 10 on both sides and we have just log equals to log, can't we set those two arguments equal to each other? So what I get here is x plus 10 over x plus 4 is equal to x. And then I'm going to cross multiply, and I'm going to put this on a new board. Okay, so I cross multiplied on that expression, on this expression right here. I cross multiplied, and then I got all of my distributed, got everything on one side, factored into x plus 2, x minus 2. So I come up with an x is negative 5 and an x is 2. But now I have to plug both of those back into the original statement. Remember, my answer for a logarithm problem cannot be negative, and the argument cannot be negative. So basically, the negative 5 has to be discarded because it makes the second log in the function and the log x. Both of those go negative. So we will cross out. Uh-oh. That's what happens when you make it in your car. I'm going to cross out the negative 5, and x is 2 is the answer. And this is Mrs. A, and may God bless your day.